Okay, so what do we get for tangent line? Okay, awesome. So it's a line that intersects the circle let's put exactly 1 point. Okay, inscribed angle. We have an angle whose vertex is on the circle. Okay. All right, so let's draw a central angle. What's a central angle? So let's write that down. Sounds like we don't know.
We don't have that for our way of problems. Our way answer this problem.
Those are just bleeders. Okay, central angle. So that's where it's an angle whose vertex is on the center of the circle. Okay, hence the word central. Okay, so let's go ahead and draw a central angle, and each of these tick marks indicates 10 degrees. Okay, so if I went from this tick mark here to this one, that would be 10 degrees. Okay, so if it's 10 degree increments, how many tick marks are there on the circle? 36. How'd you do that? 360 divided by 10. Right. So what I want you to do is I want you to make a central angle that is 60 degrees. Okay? Now, we know that the central angle is equal to the arc measure, right? So just count 1, 2, 3, 4, 5, 6. And your endpoints are there, and that should be your angle. Huh? I know. I was going to make sure that my angle ends here and here. So I'm going to go from here to the middle. Because these are in 10 degree increments. So if I want a 60 degree angle, the angle is equal to the arc.
What I'm saying is that's not straight down.
What do you mean straight down? So remember, central angles and their arcs are the same degree measure. Okay? So it doesn't matter where you draw it, it'll be fine, it'll be the same if you draw it up top, over to the left. Okay? Now what I want you to do, if you have a different color, if you don't, it's okay. I want you to draw an inscribed angle whose endpoints are at the same spot. Okay, so what's an inscribed angle? Where is its vertex? On the circle. Correct. My protractor is not long enough. Okay. So I have to look and make sure that they are going to meet at the same spot. The vertex has to be on the circle. Okay, so you should have an angle that looks like that. All right. I want you to measure the angle you just created. So I want you to measure the angle that you just created. Did you look at the thing? Anybody need help measuring? Okay, so it still works. You'll have different numbers, but it'll still be okay. So look here. Alright, does anybody else need help? Well, 150 is an obtuse angle, right? Yeah. Is this an obtuse angle? Yeah, so what? Rick? Babe, how you doing? Did you find it? This on your vertex, this little part right here. Okay, and then you have to line up one of the sides of your angle to 0. Now see how your vertex doesn't make it all the way to the circle? So it's going to mess up your angle a little bit. Alright, so where does it hit? Is this an obtuse angle? 150 is obtuse, right? Is this obtuse? Okay, so it must be the other number. There you go. Alright, so what did we get for this angle? 30 degrees. Alright, so West, I'm going to call you out for a second. Okay, he accidentally did 50 degrees here. Okay, so West had 50 for his arc and 50 for his central angle. Wes, what was your inscribed angle measure? 25. So we have 60 and 30, and he had 50 and 25. So what do you think our relationship is between our intercepted arc? That just means the arc where the angle has is in between the angle and the actual angle itself. Yes. Perfect. All right. So the inscribed angle are half the measure of it. I'll just put their intercepted arc. So intercepted arc, that just means that it's the arc where the in between the two endpoints of the angle. Okay? That is the intercepted arc. Okay? Okay. Let's go ahead and I want you to draw I want you to draw another angle using these two endpoints. Okay? But it's going to go to a different point in the circle. Okay? So I'm going to try to pick a point maybe here. I'm going to try to pick one. Okay? It can be anywhere else. You can pick one over here. I wouldn't pick it right next to it. That'll be a little hard, or in between it. Okay? So you're looking at these two circles, or I'm sorry, these endpoints with the arc, and you're going to put a point anywhere kind of opposite it except for the previous spot. Okay, so I just picked this spot, and I'm going to draw and create another inscribed angle with this same endpoints. Yeah. There you go. Is this one mine? Okay. All right, knowing what we know about inscribed angles, what can I predict about this angle? It's going to be 30, so go ahead and measure it and make sure it's 30. Go ahead and measure it and make sure it's 30. Whoop. I'll use this one to show. Some people have this one. All right, did you get 30? Yeah. So what can I say about these two inscribed angles? They're congruent. What do they share? Okay, so they share the intercepted arc, okay? So endpoints, that's fine, okay? So inscribed angles that share an intercepted arc what are they? Congruent. Perfect. Sorry. This says arc. All right. Now I want you to draw a diameter. So what's a diameter? Right, it's a cross. Okay, it has to go through the center. Okay, so I'm going to draw a diameter. I'm going to draw it in red. So it has to go exactly across. And it has to go through the center. All right. Have we all gotten our diameters drawn? Okay. So now I want you to pick a point on the circle that's kind of away from the busyness you already have. So I'm going to pick one right here. Okay? And you're going to draw another angle, and its endpoints are going to be the endpoints of your diameter. Okay? So what that looks like is this. All right, I want you to measure that angle. So go ahead and measure that angle. One second. Go ahead and measure that angle. Go ahead and measure that angle. All right, so did you create a dot somewhere? Did you create a dot somewhere? I'll do it right here.
Like, did you get 90?
Huh?
Did you get 90?
Yeah, I got 90.
And then you gotta draw from that.
90
And then measure that.
No, only for me.
All right, check with your partner to see. Oh, check with your partner to see if y'all got the same degree measure. All right, discuss why you think it's 90 degrees. Okay, but think about, we're using the diameter, right? So I want you to think about why that's 90 degrees. And think about inscribed angles are half the arc, right? So think about that.
Oh, 180 divided by 2.
Okay, well, thanks, Megan, for talking.
Oh, sorry.
It's okay. It's okay. All right, so we all got 90. Okay, so Kylie and Megan were kind of on the ball here. Okay. All right, so this is 90 degrees because we're using the diameter. What does the diameter do to the circle?
I lost my pencil.
Cuts it in half. Are you okay today?
Oh, I found it.
Are you going to make it?
Yeah, I'm gonna make it.
Okay.
It's paper airplane. I just make sure it's flat.
Okay. All right. So it splits it in half, right? So what's half of the circle?
90.
180, and then half of that would be 90. Okay? So an inscribed angle whose endpoints are the endpoints of a diameter is 90 degrees. Look how pretty our circles look. Wow. Okay, now let's draw a tangent line. Okay, so what is our definition of a tangent line? Thank you. Okay, a line that intersects the circle at exactly 1 point. Okay? All right, so what I want us to do is let's all right, so let's draw one let's do a new spot. All right. So I'm going to draw one here. Now it can only touch the circle one time. If it touches the circle twice, it is not a tangent line. Okay? So if I draw a circle, okay, if I draw a circle like this, and I draw a line, and it barely goes through it, this is intersecting the circle twice. Is that a tangent line? No. No. Okay? So it can only touch the circle one time. Okay? Now, where it touches the circle, that is called the point, because it's a point, right, of tangency. Okay, it's the tangent line, point of tangency. Okay, it's not trying to trick you here. Okay? There is. It's a very, very long proofing process of why they call it that. Yeah. So we're not going to do it because it's not really important for you to understand what a tangent line is. Okay? If you want to look it up, you can totally do that. But we will not have time today. Huh? Yes, you can do the tangent line anywhere you want. But remember, so I would pick a point and make sure it only touches that point. So it only touches my circle one time. Okay? So I want you to write kind of next to it like tangent line. All right, and from there, you're going to pick a point on the circle and draw from the point of tangency, which I want you to do that. Point of tangency. Okay, and we're going to go from there, and I'm going to draw and create an angle like that. No. You just draw it to that point. Draw a segment to that point. Okay, so now right, so you're going to draw from here to a point that you want on the circle. So maybe pick like that one. Perfect. Where's your tangent line? Okay, that's fine. But the only thing is I can't tell if that's an actual point. So maybe just draw it.
Color-coded, Lyndon? No way I color-coded mine. Did you color-code yours?
How are we doing?
Yes, she did.
Did you really?
Yes, she did.
Oh my god.
Color-coded your.
Let's try to make this.
I didn't know. I just no way I'm doing it.
Perfect.
There's no way.
It's gonna be hard to measure this with
All the females in the room color-coded, alright? We get it.
Okay, I'm still gonna walk around to that side in a minute. How are we doing? Good? Good. Okay. Alright, so what I want you to do is you're gonna measure the smaller of the two angles. If yours are equal, just pick one. Okay, so I'm gonna measure the acute angle here. Okay, so measure the acute. What does acute mean? Less than 90 degrees. Perfect. Okay, then what you're going to do is you're going to count how many 10-degree increments are from your point of tangency to the end point over here. Okay, so when I count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they're 10-degree increments. 1 second, let me finish. 100 degrees. Okay, so I want you to go ahead and finish. I want you to measure and count.
So we measure this, and then we count.
Where's your new one? Okay, so this is measuring this, right? This needs to go on your vertex.
About 35.
Then you need to line up one side of the angle with 0. No matter which side, pick one. Let's go on the vertex. I'm going to line this up with 0.
Oh, I see what she did.
I mean, it doesn't matter. You just got to pick one of the sides. And I'll use this side for 0.
What's that about?
You can line it up with the other one if you want. But it has to be, one of them has to be on 0. If it's not on 0, like when you use a ruler, you start at 0, right? Same with protract. Anybody need help over here?
You line it up with the line tangent. And then
That's because,
where the other
okay,
one?
is this for the endpoint
This
is?
is what color coding comes in here.
Oh, it's up here.
I got
So I'm
60
counting
right here.
10,
This is mine,
20,
too.
30,
That's
40,
mine.
50,
It's all
60,
goes all
70,
over here.
80, 90,
It was had on
100. Oh.
Did you get 20 for yours?
Well, everyone goes.
All right.
Another, what did you get?
35.
All right.
Do-
So I got 100 for this arc. I stole someone's pencil. Nice catch.
Am I tripping? Why is it not working?
Okay, I'll help you in a second. All right, so I counted the arcs here. Okay, this is the arc that is used between the tangent line and this chord. Okay, we'll talk about chords more later. Okay, so I measured this angle. Okay, let me measure that real quick, lock. Where is?
I got like 52 something.
Yeah. All right, so I got 50 degrees. Okay. This was a little harder.
We have the exact same one. How did you get this?
So it depends on how well you drew your tangent line. Okay, so some of y'all walked around and I said it's going to be really hard to measure that angle because your tangent line. Okay, so if it's not exactly half, that means you did not draw a true tangent line, which is kind of hard to do because we're human, right? So it might actually not touch your circle, or it might actually intersect twice and you can't see it because of the thickness of the line. Okay?
Well, we don't need our computer anymore. My son's still.
Yes, but go ahead and close it so it can. Okay. So let's look. So an inscribed angle, or I'm sorry, yeah. Created by a tangent line and a chord. Okay, so our other inscribed angles have used 2 chords to create it. So we'll talk about chords some more. Okay, is equal to, I said equal to half of the intercepted arc.
What's that word? Did I say chord? A chord?
Uh-huh. Intercepted arc. So that's the yellow highlighted arc that I did. Okay, if I wanted this angle on the obtuse angle, I would have to count all the way around. Okay, so that's why I wanted us to use the smaller acute angle, so we didn't have to count as much. Okay? All right. So inscribed angle. It's important to, where is this vertex? It's on the circle. What about a central angle? Where is this vertex? In the center. Right? The central angle is equal to its arc. What about the inscribed angle? It's half if the central angle and the arc and the inscribed angle have the same arc, yes. Okay? The inscribed angle is half of its intercepted arc. What about if the inscribed angle is using the diameter? It's going to be 90 degrees. Awesome. It's going to be a right triangle, right? Do we see how this is a right triangle? Okay. Cool. Fun times. All right. If you want to put away your thing here, if you want to put away your protractor, if it's yours, you can. If not, okay, let's see if you can toss it. Oh my gosh. What is wrong with you today? If it's on the graph, yes, but we're just going to keep it at the center if we're not using it in the graph. All right, so let's get all this down in some fancy language, okay? So today is 11/17.
Today is COVID's first birthday.
Oh, thank you. COVID's first birthday. Corona. Oh my God. All right, so inscribed angles. So it's angle with a vertex. On the circle. Okay. On the circle.
Why do teachers do that?
What?
Like they just put like one word. It's not even an important word.
It is, because it's important to the identity of an inscribed angle. Because if it's not on the circle, then it's not an inscribed angle.
I know, but like I've had teachers that would be like,
And?
what's the first word? It's like just and. I'm like, wow, what's
I have seen that. You are right. Teachers do that. All right. So we will learn about chords, but a chord is just a line segment whose endpoints are on the circle. Okay. Wow. Okay. Intercepted arc. So if we look, here's that angle, inscribed angle. This is its intercepted arc. Okay. That lies between the two endpoints. I'm digging this purple, y'all. It doesn't look that purple up there. I don't like it. It's purple. Okay, the degree of the inscribed angle is equal to half. Nice. So that means we're going to either divide by 2 or multiply by what? 1/2, right? Those are the same thing. Okay? So measure of angle ABC, so that's this angle here, is half of arc AC. If this a minor or a major arc? Minor, right? It's less than a half a circle and it's only these two left. Okay, that's from the little review day from the set. Huh? The pirate movie. You can't go to the pirate movie because it's rated R. Okay. If an inscribed, whoever's going to listen to this at home, they're going to have great laughs. Great laughs. All right. If an inscribed angle intercepts a diameter, then it is a 90-degree, or we'll put right. Okay? So measure of angle BAC equals 90 degrees. Is that blurry?
This has probably been the most fun class we've had this whole year.
What? Dang. We like measured and drew circles.
No, I'm just saying, based on everyone's energy. Like, I like what we're doing. We're just not having energy.
Actually, I'm
Hey,
gonna lie. I
hey,
like what we're
if she
doing.
likes it, then let her like it, okay?
No, I like what we're doing.
You want me to do like a cartwheel to like spice it up?
Finger backflip.
I have to take off my shoes.
Well, I'm willing.
Okay, if we get through this, I'll do a cartwheel. Okay.
That's what you say all the time. You literally say anything.
But yeah, but it's your fault that we don't, because you go, Miss
I
Higdon,
haven't talked all day long.
what do you think about?
You just said when we're
Oh,
still
okay.
on.
Oh, okay. All right.
We still have 2 pages.
Okay, if two inscribed angles intercept the same arc, then the angles are congruent. Congruent. Did you just diss me? That's what you get. All right. So measure of ABD is congruent to which angle? ACD, not the band ACDC. Okay.
What'd you do?
All right. So here we go. So I know that the arc is equal to. I'm sorry. Half of the arc is equal to the angle. Okay? Half of the arc is equal to the angle, right? That's what we said earlier? Yes, it is, Landon. That is what we said. Okay. So, half of the arc, what's my arc? 62 is equal to the angle. All right, so what's half of 62? 31 degrees. Bow, bow, bow. 31 degrees. Need a little air horn. Bow, bow, bow. Okay, well, she said it was lame, so I'm trying to put air horns in here. Right? Air horns make everything better. Thank you. I'm just going to point at you, Drew, every time I want one. What?
Do you actually have?
Did you just say no?
He has it on his phone,
Ah.
not on his computer.
Why do you have
Ah.
it just like downloaded on your computer?
I don't. I would do it.
Oh, really?
Yeah, really.
You can do that for pretty much anything, right?
Dang, that was some sass.
Oh, no, Drew gets butthurt.
Stop, don't say that. All right, here we go. DGF. What kind of arc is that? Major or minor? Major. It needs 3 letters, right? Okay. So, if the angle is 113, what's the arc? 226. Look at that quick math. Wow. Bow, bow, bow. Megan's going to have the dopest math class of her life. Okay. Ooh, look at this. It's trying to be sneaky. Do you see that? The end points are on the diameter. So what do we know about the angle? It's a right angle. It's right. Australia, mate. You like the Jersey accent better? What? Oh, I don't know if I can channel it today. All right. I want you to try number 5. It's a little different, but you can do it. You're trying to find the angle. Okay? I want you to try numero 5. Do you think I could say that more American sounding? Numero 5. Try it. Do it. You do it. Okay, well that's this arc, right? And so you want to know this arc, so you can get that angle. So remember, you need the intercepted arc. So you need this arc. So here's my endpoints. This is the intercepted arc for this angle. Oh. You can do it. I have faith. You can figure it out. How many degrees are in a circle? Wow. You may have to use your brain and math.
Why do you look like that? Why didn't you just say yeah?
So abrupt.
You were.
Wait, what did you think?
Also, everybody welcome Andrew back. Wow. Dang, y'all. Harsh.
Why'd you get that? I got 360.
What?
Well, you're
You say that, but we didn't say anything when Megan came back.
Guess what?
Yeah.
Hey.
Aw, Megan, I'm sorry. Hey, everybody, Megan's back. Woo!
What'd you get?
Back, I feel terrible.
121.
What the?
All right, let's look. Okay. So, what did we get for this arc?
242. 242.
242.
How did you get to
Megan, how are you so slow?
I don't think I have glue for a nail, dear.
Wait, who broke your nail?
All right.
How did you get 118? That's 55. I did the math in my head and it's not that.
That's not good.
All right, listen.
Oh, I know what I did.
I do not.
Did you just say you got slipper glue?
That's basically what it is. Listen.
Damn,
Okay,
you mean to me.
so
I ain't fucking done it.
does someone want to explain how we got 242? Blakely, gotta say it loud though.
53 plus 55 minus 360.
That's not very nice.
She was mean to me earlier.
You add them up and then you subtract it from 360.
Okay, so add these up. Okay, subtract from 360. Why 360? Right. Okay, so we get 242. Now what do I need to do to get to the angle? Divide by 2. Right, because the angle is half of the arc. 121.
How'd you get that?
Oh, that's how
Remember, the angle is half of its intercepted arc.
I need you to put 100 in grade for this.
Hundo.
It's only 1/3 done. It's just, it's only 100.
Coming to tutoring today. All right,
There's tutoring today.
it's
I
Tuesday.
don't want to be here by myself.
It's Martis.
Am I
All right,
going to tutoring?
so let's write our little formula, okay? We know that if we take half of the arc, it's equal to the angle, right? Right? Okay, so let's fill that in. So 1/2, what is the arc here?
Is that a 2?
Yes. What is my angle? 67. Right here. 67. All right. How am I going to solve this? Perfect. This says divide by 2, right? So I'm going to multiply by 2 on both sides. Okay, so I'm left with 4x plus 58 equals, is that 134? Yes. Subtract that 58 from both sides. What do I get? What? 76. Okay, divide that by 4. X is 19. Boom, shakalaka, shakalaka, shaka boom. Air horn. Beep, 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 beep. All right, I want you to try number 7. So write this out first so you put everything in the correct spot. Try number 7.
Will it always equal to?
It's always 1/2 of the arc is equal the angle.
I'm going to ask if that's a 2 and you said
Yeah, this is a 2.
No.
Oh, this. I didn't know you were setting that far out. Half of the arc equals angle. Megan got it right, everyone.
Yeah, Kylie, you tell them.
Oh, I got a decimal too.
Logan, what do you have to say about that?
That's all right.
I got 8.75.
Making your own too. 8.75?
Brandon, what'd you get?
8.25.
Son of a biscuit eater.
11.
I got 40.6.
All right, let's see. Let's see what we got. We got great answers out there.
I don't know
All right.
how we told me I should have done enough right.
All right, what's my arc?
158.
Oh, that's, I said
I just said it all.
Okay.
That is not what we put last time. We put
That
the
is
X
what I-
value.
Right, but I told you we have 1/2 of the arc equals the angle.
Oh shoot, I know what I did wrong.
Okay?
That's not what our example problem showed,
What?
Miss Higdon.
It's still doing the same thing. I used 1/2 of the arc equals the angle. 1/2. I'm sorry that you didn't look at which one was the arc and the angle.
I did.
I figured it out.
1/2 of 158 equals the angle. What's my angle? All right. So 1/2 of 158. 79 equals 8x minus 9. Now, if you multiplied by 2 on both sides, that would still work. You're just adding more work for yourself, okay? Because you can go ahead and simplify this, right? Okay. All right, add the 9 to the other side. I get 88. Divide by 8. X is 11.
I figured it out after we did it together.
Sure.
I first got 8.75, but then I figured
Like
out
a
that I was
goob.
trying to-
Straight up goobin'.
Yeah, and so-
All right, flippy floppy, hippity hoppy.
Almost done.
To the tippity toppy. Ba, 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 ba.
You said we could leave.
When did I say that?
Earlier you said whenever we finish you can go, and I said,
When did I? That's not.
yes, did she not say we could as we finished?
Go where? I said I was gonna do a cartwheel.
You said a backflip. That was the deal. A backflip.
my shoes off for that. I said, okay, I'm willing to make that deal.
I didn't hear that. Okay, so in a quadrilateral, instead of making us discover this, I just went ahead and I was like, we can just do this on our own, right? Okay, cool. All right, if a quadrilateral is inscribed in a circle, then it's opposite angles, not congruent, okay, but they are supplementary. What does supplementary mean? Yes. Okay. What's happening? Nice. All right. So,
I really just shot him down.
I don't know what he's saying. I can't hear him. I can't hear what he's saying. It just sounds all muffled. All right. So, angle B and angle D are supplementary. So, angle B plus angle D equals 180. All right. What about angle A and angle C? They're supplementary. Add to equal 180. Sorry, this is supposed to be 3 lines, and this is supposed to be 4.
Why?
Because they're not congruent.
Oh.
Do you need coffee? Cookies? Or something?
Me?
No, her. She just snapped at you.
I need coffee.
I worked 15 hours yesterday.
Wow. 15?
Yeah.
You just said 50.
I said 15.
No, you said 50.
I said, and then Logan said, why'd you work 15 hours yesterday?
Why?
No.
Oh.
Quarantine was great until
All right,
I got to work.
let's look. So, angle J is across from which angle? L. L. Okay. Okay, so then how am I going to find angle J? 180 minus 92, which is 88 degrees. Degrees. Just like have like 88 shoes, and like I just love the number 88. 88. You know what I'm saying?
To find K,
Right.
can't we just cut it right in half?
No.
Yeah, so we just cut it right.
No.
So 180
Hey,
minus
it's a
45.
kite.
Meh.
Yes.
No.
Kinda, you drew the line, so
Thank you. So 180 minus 45.
That's what I just said.
What'd you say?
I just said 180 minus 45.
You said cut it in half.
yeah, you did.
Yeah, cut it in half with the line like you just did.
No. Gabe, I was just showing that they're opposite.
I know, but I still said 180 minus 45. Yeah, Gabe. What did you say?
We need to finish class so we can see her partner.
There's no way we're gonna finish. We still have 1, 2, 3, 4, 5, 6, 7, 8.
We can skip over
We
stuff you
can.
were probably
Yeah. All right, let's look
not
at
that hard.
number 3. Okay, so we can find angle W easily. So that's 180 minus 51. So I get 129 degrees.
And that's for what?
Okay, now, if I look, this angle, angle X, opens up to this arc here. Okay, this is an inscribed angle. Inscribed angles are what? What's their relationship with the arc? Half the arc. What's the total length of this arc, or measure of this arc? 168, right? I just add these two together. So this is 168. So then what does that make angle X? 84 degrees, right? I cut that in half. All right, so then what does that make angle V? $96. Because opposite angles are supplementary, right? And angle Y or angle V is across from angle X, so that makes it supplementary. So 180 minus 84 is 96 degrees. It's angering. Oh, I have to put in my password. Oh my god.
Last year, and I don't even remember what class it was, but the projection thing kind of exploded, and so it made a really loud sound.
Oh.
I don't remember which
Tell it again. Tell it again.
It was either in math or in French. I don't remember. Remember that?
All right.
So then it was probably in my French class.
All right. So let's put the tangent line in a formal sentence. The measure of an angle formed by a chord. It's keep going. What?
No one else.
The back page. The
Did it cut it off?
What are we, is it just wrong? Is it just trying to stop? I think it's just trying to stop.
Yeah, but Gabe like seriously doesn't have it. Do other people have it on theirs? What happened?
No, wait, all you're missing is the line. Like the equal sign.
And the words. What are you talking about? Everything.
Okay, by a chord. Okay, chord. This is the chord.
Wait, hold on, I'll just write
And a tangent is half the measure of the intercepted,
Are these some words important?
yes, arc. Okay, all right, so if I'm looking at angle BCD, I'm sorry, yes. Oh, just angle C. So angle C is equal to half of its intercepted arc, BC. So BC divided by 2. So it's just the same formula, okay? Just it looks a little, the formation looks a little different.
If I win.
So 1/2 of the arc is equal to the angle. So angle C is equal to half of arc BDC. Okay, so that's what we did. We've done that already. Just now we have a tangent line instead of 2 chords. Okay, so that's what we did on the very front. Okay, so that's what we did with this one, the highlighted one. Okay? All right. So this is my arc, and I'm looking at W. So half of the arc is equal to the angle. So what's the arc? So that is 143. Okay. Yes. I was excited.
Just go back up.
All right. So let's look at number C, or letter C. This is 115. So what does that mean for the arc?
Oh,
230, right, because the angle is half of the arc. So I've got to multiply by 2 to get back. How does that help us with E and F? Perfect. 360 minus 230, what will that get us? But what does that tell us? Why would I just do 360 minus 230? Right, I need to know arc F so I can get angle E, right? Okay? So then what do I get for this? 130. Okay? Now, half of the arc is equal to the angle. So then half of 130 equals 65 degrees. Okay. Real quick, Leck. I'm going to do, we're going to do one problem. I might save it later. That's what, 133, 1133?
This is the,
Just wait till tomorrow.
All right. Real quick. All right. So you don't have this one, okay? But I just want to talk through it. Okay. What do I know about opposite angles in a quadrilateral that's in a circle? They're supplementary. So I know if I add these together, what do they equal? 180. Okay. You can, but it'll be more beneficial to do this. That is another method to use, yes. Yes, but what will happen is you'll get x and y in the same thing, and you're going to have to substitute a really long equation. Okay? So when you have problems like this, I would do systems of equations. So your x, okay, then I have plus 2y, and then that's plus 75 equals 180. But when you do systems of equations, it has to be something x, something y equals a number. So I need to subtract 75 from both sides. So 180 minus 75, I get 105. Okay? Now the other one, so put it in the same order. So this is 2y, and then 6x, and then 100 and negative 10 make 90. But I have to subtract that 90 to the other side, and I get 90. All right. When I solve, I can eliminate the, I'm going to eliminate the y's because they are already the same number. I just have to change the sign. So I have to multiply this by negative 1 on both sides. Okay? So I have negative 6x minus 2y equals negative 90. Okay? Add these together. 7x and negative 6x make x. Positive 2y, negative 2y makes 0. And then this is negative 90 and 105, and I get 15. So x equals 15. Now, what do I do with that information?
Plug it into all of those.
Right, so I can plug it into either one. I'm going to plug it in here. So I have 7 times 15 plus 2y equals 105. All right, so what do we get 7 times 15? Anyone for me, please? What? 105? subtract from both sides. Alright, divide by 2, y equals 0. That's just a little recap on solving systems of equations. Alright, go to, on your phone or computer,
Somebody doesn't like school. That's it. Somebody carved "school sucks" in my desk. Somebody carved it. They got good handwriting too.
alright, so you're going to go to quizzes.com. It's right, that's how you spell it. I'm going to edit. I think there's 8 questions, and I'm going to make it.
Yes.
Okay, there's 7,
I think I'm a little bit off of you.
6. Alright, there's 6 questions. Well, I had to edit it real quick. Alright. Start live quiz. Continue. Alright. So go there.
Are we actually playing quizzes?
Yeah.
Did someone get something to do?
Yeah. So top 3 get a piece of candy.
My computer's on the
It's
side.
gonna be like the actual.
I don't like it. Why
Can I
don't
stay
you
your
like it?
charger?
Hurry.
I'm hurrying.
You can use your phone, Gabe.
You don't want to be a hat.
You don't want to be a hat.
Yeah, that's not fair.
Alright, guys. Please hurry. Your homework is on Delta Math tonight.
Thank you, Mr.
We can just go
Hold
on
on.
homework.
Whose name is Haley?
It's up on the board.
Don't laugh for us.
Come on, guys. Focus. I need everyone to sign in. Come on.
Exactly.
This is an exit ticket.
Who's yes?
I'm missing one person. Come on. You're taking everyone's time. Thank you.
Missing Caboose, yes.
All right. Top 3. Get a piece of candy. Look how lit I am, Megan.
Good morning, Bobcats. Please excuse this interruption for this morning announcement. The deadline for the Tennessee Promise has been extended to December 1st. If you've yet to sign up, do so now at www.tnpromise.gov. The bowling match against South Soil is canceled for today. Seniors, the deadline to register for the December ACTs is Friday. Also, if you are a senior and you have never received a voucher, but are planning to retake ACT at any point this year, you must see your counselor to get one, and you must register for testing by this Friday. Seniors, there will be a basket please see your counselor to sign up for the fund. Available slots start at 4 p.m., 5 p.m., or 6 p.m. Limited seating is available. Your Bobcat family, the time has come to try to make you about partial day class for juniors and graduation supplies for seniors. Our Justice Roman St. Matthews will be due
he has that Mississippi accent.
I'm sorry, what?
What did you say? You do realize it's over, right?
Oh, who's the top? Alright, who's my top three? Kylie, Drew, Jessica gets some candy. Your homework is on Delta Math. Drew, Kylie, Jessica. Y'all just are jealous of these 6 dance moves. Kylie, you know you are. Don't even.
There's a couple where I thought I was gonna completely fail them on there.
That's okay. You didn't.
My brain stopped working.
You're welcome. Boom. Oh.